Hello, everyone, and welcome to another episode of the Net.lol podcast. I'm joined by my co-hosts, Brent, Dave, and Tom. And this week, we're really excited to have Roopa Prabhu on. Roopa and I have known each other for well over a decade now, so I was really excited when you wanted to join us and talk about Linux kernel networking, amongst other things. So Roopa, welcome to the show. Do you want to give us a little background about yourself?
Yeah, thanks for being
on.
Yeah,
sure. Thanks for having me. It's a pleasure. And it's great meeting you, Kyle, after a really long time. I'm mostly been doing Linux systems, Linux kernel development for over close to 20 years now. Started with HP, the small startup, and then Cisco UCS for a while for doing Linux networking drivers. And then for the past 10 years at Cumulus, I was mostly doing kernel networking, and it was a lot of fun. Cumulus got acquired by NVIDIA, and now I'm at NVIDIA. Did some DPU stuff over the last year, routing on the DPU, and then moved on to the NVIDIA Edge group, Linux systems, Edge systems, and it's been fun there, new learnings. Yeah, good to see all of you.
I remember when we first met, we were working on, 802.1 QBH and QBG at the time?
Oh, yeah.
That's old technology now, but I remember those days trying to get some of that upstream into like the Linux kernel and libvirt. Remember all of those? Like that was...
libvirt, yes, I remember. That was a lot of fun. Libvirt and VMware, ESX too. ESX.
Yeah, that was like fundamentally an interesting model of switching, right? Trying to pull everything out of the host still, and now it's like everything's flipped and it's all in the host at this point. So
yes,
we tried our best, I guess, but
but it'll happen again in another 10 years.
We just keep flipping, maybe. Exactly. Yeah.
Well, right. Yeah. I mean, if most of the stuff that we're doing today is basically the stuff we did 20 years ago, 15 years ago in embedded machines, routers and switches. The GSR has a lot of the stuff we're talking about now. The GSR has whatever.
Well, instead of trying to pull packets out into the fabric and switching them there, now we're pulling them into DPUs and SmartNICs and doing a similar thing, but just isolating the host CPU instead. So it's the same problem, but different domain.
The different spin. It's DPUs, etc., instead of an NPU. But I guess that's the question, right? Is that going to be really more cost effective or flexible or what? I mean, that's maybe one of the interesting things to talk about.
Well, yeah, and how does that interact with Linux kernel networking as well, right? Which is where a lot of look at all the advancements that have happened over the last decade in terms of Linux kernel networking. I mean, all the way from things like the Switchdev stuff, which Roopa, I know you were involved with, all the way up to the enhancements in the protocol stack to things like, eBPF and XTP, which, Dave and I are pretty fond of both of those things as well. So there's been a ton of innovation just inside the Linux kernel. And you could argue that out of all the projects we've talked about on this show in terms of open source networking, you might say that the Linux kernel was the most important one. And it's really pushed all of that. I mean, even the things we talk about, Open Daylight, Open vSwitch, they're all involved in the kernel, and they all help to orchestrate that.
They all depend on the kernel.
They all depend on the kernel, and they all do that. Yeah. Yeah, so Roopa, talk to us a bit about Switchdev a bit and some of that early work that you all did there, and how did you bring all that forward and get everyone on board in that?
Yeah. This was 10 years ago, right? 10 or 11 years ago when the open networking revolution started. And Cumulus had a great take on it. Basically, make the rest of the fabric, data center fabric, same as the hosts and servers, right? That was the whole idea. Make everything look like a Linux system. And a great thing what Cumulus did was not only had that idea and started on that model, but also started hiring operating systems developers for networking, which was unheard of. So that was a great mix of people coming together from Cisco's and traditional networking operating systems, and then, the host side networking. And since it was a startup and we did not have an agreement from a vendor to actually write a driver for Switch ASIC in the kernel already, we had a model where we had a user space driver to actually kind of make all Linux networking kind of work with the SDKs that every vendor had. And that was fun. It was re-implementing a problem that you would implement in the kernel, but kind of think about it in a different way, trampoline to user space and so on. The core idea was to use the Linux hardware acceleration model, right? So the way Linux hardware acceleration model works is the kernel works without hardware, but if there is hardware and a driver indicates that it has support for acceleration, it advertises that, and you get seamless acceleration. That's the whole model of Linux networking and Linux hardware acceleration, and that's what Cumulus was trying to bring to the switching ASICs. So back then, J.R. Nolan and Shujit, some of the names if you know, and Scott Feldman, who is also who started one of the founders of the Switchdev project. We were sitting in a room and trying to understand. I mean, Scott and I talking, why do we have to go to user space for all this? It would be nice if all this was in kernel, and maybe it's not too early to start that discussion, right? To get vendors talking about it. So I remember there was a meeting with Red Hat, and this was long ago when we got that, people thinking about it, vendors and operating systems. And Scott got very interested in, starting a project around it. So that's when the virtual Switchdev model came out, like a rocker device. And then there was a person, Yuri Pirko, who was at Red Hat, and he was very fond of that idea. And he joined Mellanox because Mellanox wanted to kind of create that driver. And so that driver development or the project actually we announced it in some NetDev conference long ago, almost 8 years ago, I think. And then Mellanox was the only driver, but that driver was getting built in parallel to what we had, right? What we had a user space stuff, which was working with Mellanox and also Broadcom, because we had to support multiple vendors. And not every vendor is going to leave their SDKs and start developing a Switchdev driver. So that's the classic problem, right?
Of course.
So during the course of time, I mean, we were working with the Switchdev. So both of these tracks were going on in parallel, but the unified view was the same. You develop the enhanced Linux networking for data center fabrics, like, add VRFs to the kernel, add all the bridging, various obnoxious knobs that you need for a switching NOS to the Linux bridge, and and then try to see if the Mellanox driver can take over. Well, there's a lot of stories around that, and then I can talk about the Dent project also later on. But so the VRFs came along, then routing scaling. As you guys know, the traditional Linux kernel routing is a prefix and next hop together, right? And you can't scale that because traditional network operating systems do it different way, next hop groups and indirection and so on. Yep. And that was a major overhaul, right, of the Linux routing stack. And we ended up doing that too, to kind of support the data center scale.
Yeah, that's another example of something that we did 20 years ago in embedded routers, right, to make, the internet work. But now it's kind of catching on, and it's interesting how server architecture has evolved too in that regard. And the kernel is pushing that, right? Kernel is saying no, we can do this. I remember people saying that's insane, you can't do that. Well, you did it.
Exactly. And the best part is you do it once, it's in open source, you enable, we had then customers moving the network stack from the switches to their hosts, right, hypervisors. we have customers still running that. Take the routing stack, as long as they have the proper kernel version, you can do
Yep.
VRFs, you can do, next door groups.
That's the cool part about doing this in Linux. It appears everywhere really fast.
Yeah, exactly. Yeah,
Relatively fast. But I mean, within a couple of years, it's everywhere. It's available on your phones and on everything else.
Yep. Yeah.
Well, I was waiting for Brent to bring this up because he usually does, but I'm going to bring it up. One of the other interesting things that all of this did from an operational perspective, you said, well, we have everyone's, the server admins are used to administering Linux. What if their switches were just Linux? And they just administered them the same way, so they know how to administer. They're just another host. I mean, yes, they have a specialized ASIC on them, but the interface should be the same. And people forget that was pretty fundamentally different at the time. I mean, and now a lot of the times people just take it for advantage, right? Or, like you can just log into your switch, but back then you couldn't do that. So that was also a pretty big thing.
Not even back then. I mean, I was working with a couple of vendors 2-3 years ago who were basically using the older style that Roopa described, where there was, you call out to an NPU on a NIC, etc., and they would actually build a switch fabric in front of a little Linux machine effectively, and that was a switch. I mean, it was, it was kind of, the natural progression of that stuff. But they encountered really the same scalability issues Roopa talked about and a bunch of the other things. Like even if I'm going to build a 24 port bridge, switching bridge, you can't rely on the kernel to do all the switching. It just won't work right. And so it's, you got to, what we're talking about. And the question is that the most cost-effective packaging for that kind of thing, or what we're talking about here, like something like BPF potentially on NPUs, DPUs, I mean.
And the whole Linux ecosystem, right, suddenly becomes available to all the devices. That was another thing that people loved. I mean, customers loved monitoring tools. You grab a open source monitoring tool that worked on servers, you can move it to switches and so on.
Oh yeah, that's huge right there. Being able to take advantage of all that existing
we talked
software.
about that in one of the BPF things recently. Well, even in our talk that we did, you and I did, where that's the important. Who was it? Maybe it was Tunk who was talking about this. When we're talking about the next thing that's needed around this is more tools, more integrate into all the usual tools.
Well, and that's the general thing is, a lot of these cool technologies and things that people talk about, they're definitely really cool, but, getting them to be used and how people can actually operate them and deploy them and rely on them, that's usually the challenge. And that
I remember when like Schulman was on, he was talking about this too, the necessity to, you can't automate everything unless you have access to it, and having access to it in a clean, consistent way is a real advantage to that, right?
Yeah, and I think we still have a disconnect between kind of the hardware networking traditional fabric and the edge. So, this week I had a thread on V6 on Twitter, and it was like, well, we've got V6 deployed. It's like you might have V6. It's really easy to deploy V6 in your backbone. It's really difficult to deploy V6 in your load balancers. And now that we're disaggregating load balancers and everything else, all the services that go with it, it's a different story. So I don't think the same tool sets aren't available for the networking person that there are for the edge person. But Roopa, what is really so impressive is that you've been working for a decade and making those interfaces available on the Linux edge. So what would be your preferred stack? For me, it's always going to be the Holy Trinity: IP, BGP, MPLS. But I don't know. One of the interesting things over the years that I saw everybody at Cumulus was put, EVPN. I think you all were one of the biggest proponents of that. So, what is your ideal stack after 10 years of doing this? On the edge. Now that you're on the edge, I think the interesting pieces are the edge. So, if you had your druthers, what is it going to look like over the next 5 years?
Yeah, I think it's EVPN for us, data path routing and bridging, right? I mean, that's what we've been preaching. Pure routing, first look at routing, pure routing, and then, if bridging is needed, then we bring L2. And it's been amazing. As you know, Cumulus was one of the maintainers of the FRR project, and you have seen so many books around EVPN, and Dinesh has talked about it, JR, and everybody else. And still today, I mean, we try to push that technology, right? Anybody trying to even try to get our technology onto the host or DPU, we kind of move them towards that direction. Oh, you can do routing just fine on the DPU. And in terms of hardware acceleration, Linux today, you can do EVPN completely in software if you want, right? You have the routing stack, you have the Linux kernel interfaces, required interfaces. And then if the hardware is capable of supporting acceleration, you can add acceleration to it. But yeah, virtualization, VXLAN, and control plane EVPN. That's still the easiest to, at least from our perspective or my perspective, easiest to operate. And there's so much literature around it already, standardizing on it.
Do you mind elaborating a little bit on FRR? So, I think when FRR first came about, I'm like, why are we talking about fast rerouting?
Yeah. Who picked that name, by the way?
But,
I've been asking that. I asked JR that too when I talked to him last year. But
Yeah.
who picked this name? This is very confusing.
So
I don't know the
dinosaur operators like me, I always hear fast rerouting. But so it's basically Quagga, enhanced Quagga. So Quagga code base was a disaster over the years. There was probably like one or two people that could actually figure out how to make changes in there. So I guess
I think the larger problem was the velocity of development in Quagga, right? That was the major problem. Yeah.
So, I mean, what is the state? But while we're there, what is the state of FRR these days? Is it still carrying
thriving?
Okay.
Sorry?
Just just for the for people listening. I mean, is it still a viable community? And
oh yeah, it's a viable community. It's a thriving community. There are a ton of maintainers, many maintainers, not just NVIDIA or Cumulus, but beyond that, there is VMware and many of the other players also. Sonic uses FRR, if you think about it. Dent uses FRR. All the operating systems, network operating systems use it. And there are a few who also use it on the host and hypervisor.
I think it's an LF project now. Is that correct?
Yes, that's correct.
Yeah, I was thinking it had moved in there at some point and that. So yeah, that's interesting. I think so. Tell us a little bit about Dent as well, because that's a newish thing, right? Over the last few years.
Yeah, it's a newish thing. Right before the pandemic, actually, it started.
Yeah.
So it's a project headed by Amazon Go for their edge retail stores, right? And it's a Switchdev based NOS, is such a lightweight NOS. Basically, you boot the system, and if you have the right hardware, like any other Linux system, you get hardware acceleration. So Dent is again a Linux Foundation project. It started, like I said, when did the pandemic start? It's like 2.5, 3 years ago. And what they are doing is initially it's for the distributed edge, for example, the Amazon Go retail stores. And the vendors is interesting because for the longest time you had only Mellanox NVIDIA as the only Switchdev vendor, right, which supported a driver. And they have had customers of their own who like DIY, who like maintaining, using their Switchdev driver and maintaining their own NOS. But in this case, the main goal was to get more vendors into the game. And Marvel was one of the vendors who joined the Switchdev project and, developed a driver. It's deployed in Amazon Go stores. And I'm told, or at least I can't say for sure anything about Amazon, but, they are proliferating it in the parts. But yeah, it's an open NOS project. It's like Sonic. It's they're looking for more operators to get on board, more vendors to get on board. But the feature set is small to tailor to distributed edge systems and retail edge. But yeah, the Switchdev ecosystem is, supports data center as well. So let's see where that goes.
It's interesting because, I mean, there's like you said, Sonic is another open source NAS, and I think we remember from years back there was ONL as well, right? Open Network Linux.
Yeah.
But what's interesting to me is I recently started to look back at ONL, and it seems like AWS, so different than Amazon, they've rebooted ONL at this point. And
Really?
they're like, yeah, ONL is now an active community again, all from AWS. And it highlights a couple of things. Number one, first of all, how many open source NASs do we need? The answer might be 3 or 4. But second of all, it highlights maybe the distinction between Amazon and AWS, internally, and which people seem to, forget about, I think, a little bit. But yeah, because I was surprised to see ONL somewhat active. So I think I saw Steve Noble, if folks remember him. He seems to be
Yes, he's
doing a
the
bunch of
Dent
stuff with
project.
that. Oh,
Yeah.
he's still in the Dent, so who knows? Maybe they're going to combine them.
So Dent uses ONL, so
Oh,
that's another angle there. And
that makes
ONL
sense.
is owned by OCP, right, which I'm also
Yeah,
part
that's
of.
right.
But ONL, wasn't it the Big Switch and Arista acquisition kind of changed that, and they're trying to figure that out right now. I mean,
Yeah,
who maintains ONL?
yeah, I agree. I think, and if I recall,
Yeah.
I think Steve was at Big Switch at one point.
Yes,
He might have been
he
working
was
on it.
working on
Yeah, I think
Yeah,
so.
yeah, and I think my current boss Rob was one of the original guys on ONL, if I remember right as well. But
Oh,
yeah, it seems like they've made it active again. I mean, if you go on
yeah.
GitHub and take a look, there's committers, and in fact, I think Steve might have sent an email in the fall saying that they're looking to reboot it and get more interest in ONL. So yeah.
Okay.
Yeah, it looks active. I mean, maybe Intel
But
should take a look at the logo because it looks like Intel Inside logo now. But
Well,
it's not much
speaking
of
of
a
things
Kyle's
that
nervous laughter.
speaking of things Intel should look at, Kyle, I hear there's this cool thing called Switchdev that
Yeah.
Intel might also want to pay
I know
attention
exactly,
to.
exactly.
Maybe.
can I?
Not joking around, but I mean that from me as a not vendor perspective, and especially with the increased amount of focus that there is on DPUs and SmartNICs right now, I think that's really top of mind for me. Is like what is this going to look like, and what is going to be the interface for dealing with these things? Because there seems to be I guess 2 ways of looking at it. One is bypass the kernel completely, or have your own kernel and then have kernel to kernel communication happening somehow, which seems a bit weird because of the reasons that Roopa you've enumerated before. And like, there is a good reason to have everything in the kernel and the tooling centralized and everything else like working together because it enables this cool ecosystem.
Well,
And then we
also in
also
the
have
same way, right?
in the
Not
same way,
the
right?
thing
And not in
we're
different
not
ways with different
appreciating is
SDKs. Yep.
right, and the thing we're not appreciating is that the kernel that runs on the hosts, has to collaborate with the kernel that's running on the NIC at NICs, and if they don't, what you just said, right? I mean, this is much into, like there's a bunch of different versions of these out there, and commercial and otherwise, we're meshing NICs now,
Yeah.
and right as
Yeah.
part of like virtual extensions of the host and stuff, and so there you'd hope for consistency too, not just making it work wise, but operationally, back to the tooling, right? I can't have separate tools for the Linux edition I'm running on the NICs versus the hosts. That's bananas, right?
I agree.
Or even
Yeah.
kind of heading back to the way that it was before of like, here is my Linux system admin tools, and then here is my Switch admin tools, and this is the thing that I can't SSH into, or needs to run a custom kernel, or has all of these weird drivers, then I don't know how it really works. Like, so I guess the
Well,
question back to you, Roopa, like, how do you see this space evolving, and do you think that Switchdev has a place here potentially?
It does. Again, it comes down to vendors, right? Vendors and how many vendors come on board, and um, yeah. If you see, there are other solutions as well for the NICs, like you mentioned. There are DPDK forwarding paths that some customers prefer, or some vendors are pushing in that direction. Actually, even recently, a conversation at OCP on the NIC side of things, every vendor is implementing different things different way. There are subtle differences, and the hyperscalers are making a call for, can you guys unify this thing, right? Let's make a software spec on how do you guys deal with even stats, for example. Linux kernel is also not very consistent there. Every driver
That's
has
what I
different
mean by
streams.
that
Yeah,
operational stuff.
Yeah.
This
yeah,
drives operators bananas, you know?
yeah. And you can imagine for the hyperscalers, it's dealing with multiple vendors, multiple
Hmm.
places where they put their software. I think it's a great model. It's just that, again, all the vendors coming together, it all depends on that, right? And major operators adopting it, basically.
I mean, I mean, this kind of gets into the open source community thing. Is it that angle that's missing to make that, or is it just the vendors doing the vendor thing,
Yeah,
or both?
no, I think the Linux kernel community is, for example, and the Linux kernel networking community is very small. The whole networking community is small. You'll see the same people everywhere, but
Right.
Linux kernel networking community is small as well. And you will see people move in the circle of these vendor communities, and they are all on the same page, right? You will see the developers on the same page. But then again, getting more vendors into that community or ecosystem is always a challenge, right? You can see Intel, Mellanox, most of these major guys are playing great, right? Marvel has just joined in the Linux Switchdev space, and they are slowly but surely trying to get their drivers upstream.
Hmm.
But I can say that, if they have an option to not upstream or have that path taken away from them, I mean, they'll be happy to go any other way.
But
So
that's
it's
a real
also,
challenge for the host vendors then. I mean, I had this
yeah,
problem when I was at Red Hat where you had, you know, drivers that were out of the tree that they're, oh, I've got a special one that's going to work for this special version of the, it was nuts. It was like, that's
yeah,
my suggestion to the vendors. Upstream your drivers, there's nothing secret in there. Gosh, just
yeah,
make it easy for us all.
Well,
yeah,
it comes down to users as well, right? I think vendors will only do this if the users insist, because the incentive isn't there otherwise. So, as
exactly.
a consumer,
Right,
you want to
right.
say, look, no out of tree drivers. I'm not going to buy the thing if the driver is out of tree, because it's going to cause a headache for me.
I've already
It's going
done
to
that.
cause a headache for my OS vendor.
I
So,
won't mention which
Yeah,
vendor, but I've already done that. I said, no,
Okay.
what? No, I'm not chasing drivers around. I've got enough to do. And especially these NICs are expensive. The high end NICs are very expensive. And you're like, it's like buying a Tesla with no software update plan or something. What
yeah.
are you going to manage the car yourself in your spare time?
The other important thing that I do want to highlight is the whole virtualization benefits, right? Um, so, like I mentioned, the Linux hardware acceleration does everything in software, and it does a seamless hardware acceleration. And Cumulus used that to a great extent. So basically, our Switch OS was nothing but a Linux virtual machine um, running the Linux kernel, basically, right? So we never used to wait for hardware to actually develop a networking feature, right? Like EVPN, for example, we could prototype it and do it completely on a Linux virtual machine, and then hardware accelerate. Our driver would come in and seamlessly hardware accelerate, and that was a huge advantage because you
Yeah.
could simulate a topology, simulate a data center fabric without having the hardware, right? Same thing with segment routing and a bunch of other things. So that's been Yeah, and that ties in actually into the NVIDIA digital twin story, where you can have a digital twin of your network running in parallel with the hardware.
Yeah, and that's huge for, I mean, so as we start talking about kind of the evolution of NetOps to where there needs to be like, you know, CI/CD type pipelines, you know, and being able to emulate changes before they go in, I think there's tons of opportunity there, and it still really hasn't been kind of exploited by
Well, also
vendors.
security scanning, our topic from a few weeks ago. You know,
Yeah.
that makes that stuff easier. You
Yeah,
know, doing pen testing, doing that kind of stuff. Not just your usual CI, you know, type stuff. You know, that's where some of the most insidious bugs are found, and is in a big topology like this. I mean, way back when, you know, at Cisco's and Juniper's type places, you had a building full of the lab, which was the lab, you know, to simulate what you're talking about. Now it's, you
yeah,
know, rack of servers and we're all set, but we can emulate that stuff faithfully.
yeah,
So just
yeah,
imagine that you're on the customer end of that, and you're not at a Cisco and a Juniper, and you still need to make that level of investment in equipment because you're the one
Mhm.
that's going to find the bug in the BGP implementation when your theory says, oh yeah, this change will be fine. Like, you know, it should work that way. I know
This
my
change
specs, like
should be
everything's,
fine. Yeah.
and then you
Yeah.
actually go and do the change, and then it's like, oh yeah, there's
Oh,
that bug. Let me phone TAC and spend 3 hours on the phone trying to
why is the
figure out
data
why this
center
broke.
on fire now? Yeah. Oops.
Right. So like having that accessible to people today, you know, is incredible. Like that, just verifying the practice rather than the theory. And
yeah,
that should be massive for NetOps.
It's also a game changer just for dev, you know, I mean, for feature development and all that. I remember when I was at Cisco way back when we came out the first virtualized version of iOS at the time, and
yeah,
how cool it was to be able to, you know, not have to run into the lab and reboot a thing every 10 minutes or whatever, you know. Um, and it really, what it did though, my point I'm making is not being nostalgic, but um, it accelerated a lot of our development, and it also weirdly enhanced, you know, what was called QA at the time, and it really gave the QA team, kind of all this weird dimension of flexibility to really just beat the
yeah,
thing up and play, you know.
yeah,
And this is even more, you know, this is like complete machines you're talking about now in a huge
yeah,
topology.
Did you all call it
yeah,
GNS3 then? I mean, so I think there's still a disconnect on delivering it to customers and users, right? Like we've all got our own little custom in our development environments where we're able to kind of, you know, set up these relatively fixed environments that aren't necessarily dynamic, but we do some testing, but it's nowhere near thorough enough to replicate the real world. Um,
It's
yeah,
too static, right?
yeah, I'm curious. Maybe a little bit more about the digital image you mentioned, Rupa. That sounds really interesting. Like,
yeah.
is there a mechanism that users can use that, or is that still kind of just developer focused?
So I can say that the Cumulus had the what was that Cumulus Air, which was a system or a cloud where customers could deploy their topology virtually, and that is kind of right now it's being since NVIDIA uses digital twins, the name digital twins, and I think digital twins is common right now, the word itself, um, to simulate environments. So it fits into that as well. They're repositioning it, but I think the interfaces remain the same. Customers will be able to log into this, register for an account, and try their entire setup. For example, the AI Launchpad, right? What NVIDIA is pushing for as well, having that is truly NVIDIA physical gear sitting in Equinix to for people to try out and try before test out and before you buy. But the similar thing that runs entirely virtually, for example, for Cumulus Networks, is in sort of a cloud. And yeah, so That's where things are.
That makes sense. I mean, it kind of has to, you know,
Yeah, yeah.
if you're going to
And
offer it
if
as a
you can
service
imagine,
like that.
yeah, and you can imagine, right? NVIDIA is a lot into with all this metaverse and all the simulation stuff. I mean,
The
they're
metaverse of
simulating,
networking.
yeah, and you're simulating, they're simulating, well, entire worlds. Yeah, the planet. So, yeah, um,
Yeah, I mean,
things
at a
are,
minimum, I mean, it's an interesting, you know, test bed POC type thing. You can
yeah.
experiment things in a non-destructive way, I guess, right?
Yeah, yeah. And you mentioned QA, right? For example, I mean, I don't think, Cumulus products were great quality, and our QA used to run like with one switch in a 80 node topology, right? One hardware switch. Everything was
Mhm.
else was virtual. And then you rotate that hardware switch in different positions in your network, and you that way you get coverage. But I remember back in the days 15 years ago when I was at Cisco, you literally, like you said, they had huge labs to
Yeah,
so much of investment to test an image management solution. You can imagine that
it was
cost.
it's really funny. I mean, after I left, you know, Cisco or Juniper, those places, they had these massive labs. I've worked at a few other places since, and it
Yeah,
it's really disheartening when you walk into the lab and you go, "This is all we got," you know. And but
yeah,
with a
yeah,
virtualized
yeah,
version of this, and this is like what we do where I am now, you know, it's most of the testing is capable to be done virtually, but it's like the thing you were saying, Rupa, that there are still some hardware things that you need to test and you need to try all those combinations. As a friend of mine, his wireless NIC is screwed up right now with virtualization, and I was helping him earlier before we started, and it's just a weird kind of insidious little config thing that he screwed up. And unless you're running through these weird things and checking them, you know you're not going to find them until the
yeah,
user does.
yeah,
So that's really cool. You know, being able to have the most faithful. You know, like you said, if it's really simulating the entire thing, you know, including the hardware, that's magic. Yeah.
Cool. Well, I think we're getting close to wrapping up. But Rupa, I wanted to ask you one question at the end, which I think would be pretty cool for our listeners. So, what advice would you have for somebody who's looking to contribute to the Linux kernel, or maybe looking to get into kernel, the kernel networking, and hasn't really been involved there? You know, whether it's an individual or someone from a company or a vendor or something. Do you have any advice for kind of a first-time Linux kernel contributor?
yeah. I mean, today there are many communities as well that help you get into Linux networking. Like there is an outreachy community, but if you don't, I didn't start right fairly, but you look around the mailing list and try to see get the pace at which each subsystem that you're interested in, right? And there is kernel newbies where you can start with, or at least understand the process. So if you are a hardcore networking developer and then you want to contribute to Linux networking, it's always, great to start with reviews maybe. First, subscribe to the mailing list. It's high volume, but you can, yeah, if you manage how you delete emails, it's you can get through it. And commit logs and look at it's all open source. The discussions are open source. And one thing that I love about the kernel community is they take that effort to actually write a great commit log message, great cover letters. There's lots of that, right? Dividing your patches into multiple things so that every person can follow. So I think following a kernel community trail or a trail for a feature, I think it's easy, but you have to take that initiative to actually listen to watch the mailing list and, build a kernel. And Outreach is a great place though. They're doing some great internship opportunities for new beginners in kernel.
Mm.
That's
and
awesome.
other open source communities. Yeah.
That's super awesome advice. Well, thanks so much for joining us. It was definitely a pleasure. We'll definitely have to have you back in the future. There's a lot of other things I think we could discuss on the show as well.
Same here. Thanks for having me. It's
Thank you for being on. It was
Thanks so
great.
much.
Yeah.
Great.
It was excellent. And as always, thank you to our sponsor, T1 Nexus. We appreciate your support of the show for sure. And
Look forward to some T-shirts soon from T1 Nexus.
that's
folks.
right. It's coming out. So as always, you can find all of us on Twitter or at thenet.lol. So thanks a lot for listening, everyone.